I'm going through this AR musical instrument. I made a wall piano, so it's a projection mapped piano that you can play with body tracking. So I'll go through this real quickly. The first thing is that I'm calling it an augmented reality adaptive wall piano. XR or AR is extended reality, augmented reality. It's used for simulation and training, and when you apply this to a musical instrument, you can create an adaptive environment where you control a musical instrument with your body. So I'm making an AR-enabled musical instrument at the request of a special education teacher and principal of Ann Darling Cluster. It's a cluster of special education schools in Santa Clara County. This school is located in San Jose, and from research, this type of instrument is called a modular accessible. My objectives were to create, firstly, a musical instrument that works with the classroom. So there are special education students that need a way to play a piano or some input because they're going to use this for a musical program, so they could play the piano through motion, gesture, or body movement. And the second objective is to actually have a working prototype so that the principal and special education teacher can use it for a new music program. So the curriculum will be designed around the instrument's capabilities and the mapping that it affords. The main features are these five. First is that it's a web-based platform, so it runs in the browser. Secondly, it tracks the hands and wrists. I'll show the progression of how I was able to do that. Third is that the users can move their wrists across the screen and activate sounds instead of having to press a button. Fourth is there's a user interface that allows you to change the types of sound. And lastly is the final setup. It's that it's projection mapped onto a wall. This part is optional. You need to know the bounds of the wall. In this demonstration, I'm showing the laptop screen, basically. And a quick before and after. The traditional piano on the left, and then on the right is where you use the full body. This is the concept art for it. So I'll start showing how this looks. From this report, I'm going to highlight the features. So this is a screenshot of me and the overlay of the notes on the screen. At the bottom, there is the types of scale. So I chose a major scale, minor scale, pentatonic scale, activating these chords on the screen so it can become more of a musical. So you can see it's tracking my wrist, and at the bottom I changed the type of scale, so now it sounds different as you move your wrist across it. In some of our testing, you can see what happens if there's multiple people. In this case, me and my friend Lack here, who's advising on the software development. But if there's multiple people, it kind of gets confused about the wrist, like detection. So for how it's built, we made this with vibe coding, and in that case, I'm using Claude Code and VS Code. So these are accessible programs, and I hosted it on GitHub, which is a place where you can put repositories and make it accessible to the public. Vibe coding is a term that's useful to know. I talk about the history of vibe coding, but it really started last year, where we focus more about the quick iteration mindset. So it's the development of the program and the design, and I think of it as a human-centric design approach, so we know more about the features that we want and like the product design versus the line-by-line thought of coding. So this vibe coding idea helps people who have no background in coding kind of iterate and create products quickly. So it makes it super accessible for anyone, and that itself has an affordance. It means that I'm able to design the instrument really quickly, even make changes after doing some testing or exploring different features without having to wait for a software engineer. So the affordances of the platform itself, I have to cover the learning objectives, which I created with the principal, and it really started off by this prototype that I had, which was also vibe coded. It's a laser harp, so it's hand tracking features allow me to play the laser harp using my fingers. I'm actually using my left hand in the screen to change the kind of like the pitch or the octave, and my right hand is used to play the note itself. So if I close my hand, I can deactivate my finger, and if I open my hand, it activates. And then my left hand depending on the y-axis, how high or low I put it. It will play a different octave or pitch. And you can also play it with both hands. So the basis is that you can vibe code, you can create technology that is augmented reality, like it overlays onto the real world. In this case, you're looking at a screen. You could projection map it, which is the AR part. These are alternate controllers from my research. This one is called Soundbeam, and it's also creating accessible music. So this highlights how they use this in a school or clinical setting, or in a care home in this next example. So the affordances of how does music allow people to play in ways that they couldn't before. So the fit for the technology to the music program is pretty clear. In my case, we're creating these objectives. So I used Bloom's taxonomy to create some learning objectives based on conversation with the principal. The first is application. Can the students activate or produce musical sounds? So the affordance is that you can tailor this musical device to their motor disabilities, whether they can move their wrist or fingers. The next is synthesis. Can students independently manipulate and play with sound effects, volume levels, etc.? So you could have them change levels or effects instead of playing notes. So it just allows different ways of learner agency that was otherwise not possible. And the last one is evaluation. Can the students construct musical compositions, go into complex design, really, with the help of either an assistant or the adaptive instrument by itself, plus the software that can do music, such as GarageBand. So the affordance is that you can make this part of the process of music production. You can take the inputs of this piano, record it, and then add it to software, which will be helped by the aid. And the other affordance is that you can have multiple students play instruments together in this case. One student who needs the adaptive piano can now play music with another who could use the same type of software or just any kind of. So that lends itself to constructivist learning theories. So the product is engaging, and I cover that a bit here. And the last part is the pricing. So there's the pricing for the vibe coding, the software, the hardware such as the webcam. And I also cover that one challenge is the maintenance and setup. So the problem of a lot of these technologies in educational spaces that they're bespoke or one-off technologies. So in theory, the maintenance would be supporting it, creating a platform for it, and having a team behind it or some kind of sustainable way keep it alive so that teachers can use it and scale it and use it in different environments without having to rely on the person using the product. So the future work is using this product and testing it out in the environment with usability testing. And I also summarize it as these three research topics or research questions: functional capability, sensory mapping, and system resilience. So the future work of this is, does the range of motion of the user match up to the triggers that we program? Does the mapping work intuitively for visual and other types of users? And lastly, do teachers and students find the system easy to set up and maintain? So that is the recap and current progress of this AR music piano.